All right, so now we're going to talk about applications of exponential growth. A lot of the word problems involving these deal with money problems. So now we have y equals ab to the x. That's our growth equation. But now instead of this b value, we're going to call it 1 plus r. So a is your initial amount, or the initial amount that you're investing. R will be your rate of increase. It will be some percentage that you will have to change to decimal form. 1 plus r is what we refer to as the growth factor, and t is time. It must agree with the rate. So if your rate is 3% per month, then your time has to be in months. Or if it's 3% a year, then your time has to be in years. And y is the final amount. So let's go ahead and take a look at an example. In 2005, some state university charged $8,500. In the years that followed, the tuition rose 3% a year, and it wants us to write a model. Anytime you want to write a model, y and t should be your variables. So if we define our variables, the number of years since 2005 would be our t, and the tuition is going to be our y. So our model will be y equals, well, the initial amount was 8,500, so 8,500. 1 plus the r, 3% is our rate, but we have to change that to a decimal, so 0.03 raised to the t. So that is now our model. Blank is the rate of increase, so 3% is our rate of increase. And the growth factor, remember the growth factor is the stuff that's in the parentheses, so 1.03 would be your growth factor. If we wanted to make a graph of this model, we would just go to our calculator and we would put our equation into our y editor. We would say 8,500 times 1.03, and now we're going to raise that to x. Instead of using t, I'll use x. And now I'm going to have to set my window. I'm going to set my window from 0 to, I'll say about 25. And my y's, I'll go to about 20,000. And if I hit graph, you can see here, this is what our equation would look like. Remember, if you're going to be putting that equation on paper, you need to label both your x and your y axis. They can ask another type of a question. Now they can say, what will the tuition be in the year 2012? Well, if you remember, this problem started in 2005. So what they're really asking you is, what is y when t is 7? So we would just put that our equation, y equals 8,500, 1.03 raised to the 7. We can just go to our calculator and go ahead and put that in. 8,500, 1.03 raised to the 7. And if I hit enter, you can see that the tuition would be about $10,453, $54 if you round up. You can also do this by using, since you've already graphed this, if you can go to your graph, you could hit second calc. And then if you hit value, you can put in any x value you wanted. Our x value was 7. And if you hit enter, you can see here that y value gives you the same one that we just calculated. Another question could be, in what year will the tuition be $15,000? So now what they're doing is they're giving you a y and they're asking you to solve for a t. Right now we can't do this algebraically, but that's really what this whole chapter is about, is solving for variables that are exponents, but we haven't gotten there quite yet. So the way that you would want to do this one is to go again back to your graphing calculator. In your y editor, you could put that 15,000 in y2. And then when you graphed it, you just very simply would use your intersect, that second trace, and then use your intersect button to find out where they intersect. On the bottom, it says first curve. You can see it's kind of flashing on this first curve, so I'll hit enter. It jumps up to the second curve, so I'll hit enter again. And it says guess. Yes, I would like you to guess. And then it tells you here your intersection is at 19.2. So what that means here is that x equals 19, and since we started in the year 2005, if I add 19 to that, in the year 2024 is when the tuition will be about $15,000. The other equation that we will have to talk about today is compound interest. So now the interest is being compounded by some certain amount of time, monthly, yearly, daily. So this equation is A equals P, where P is, again, your initial amount, 1 plus R. Again, R is the rate of interest in decimal form. But now we have N, and N is the number of times that it's compounded per year. So if they said it's compounded quarterly, that would be 4 times a year. If it said compounded monthly, that would be 12 times a year. If they said compounded daily, that would be 365 times a year, and so forth. And then T is your number of years, and then this equation is raised to the NT. So the number of times it's compounded times the number of years. So let's take a look at an example of this one. $2,000 is deposited in an account that pays 3% annual percentage rate. How much will be in the account after 2 years if the account is compounded quarterly? Those are the words in the word problem that you're going to want to look for that kind of clue you in that you're going to want to use this equation, this compound equation. So now let's fill in what we know. Well, $2,000 is deposited, so that's our P. The rate, 3%. I have to change that to a decimal, so 0.03. It is compounded quarterly, so that would be 4 times a year. So I'm going to say 4 times T is 2 years, so 4 times 2. And again, now I can just go to my calculator and I can put this into my calculator. I can say 2,000 times 1 plus, I'm going to put parentheses again to put the 0.03 divided by 4 in those parentheses. And then I have to raise that to 8. 4 times 2 is 8. And you can see here that if I deposited $2,000, I would end up with $2,123. And again, the question could say how much should be deposited in an account that pays 4% compounded monthly in order to have $5,000 after 3 years. So now again, they're giving you the final amount. But now they want you to calculate this initial amount. It is 4%, so 0.04 divided by the number of times it is compounded, which is monthly, so that would be 12. And we're going to raise that to the NT, so 12 times the number of years, which is 3. So now I just have one equation and one variable. Remember that this stuff here is really just a number, so I'm going to go ahead and get a number for this in my calculator, and then I can divide it onto the other side. So if I go 0.04 divided by 12, and I can add 1 to that. That right now would be my growth factor. I'm going to raise that to the 36 because it's 12 times 3. So now here I have this number 1.12, which was all that stuff. And now I'm going to have to take 5,000 and divide it by this number. I'm just going to go second answer so I don't have to type it in. And here now I know 4435, that P is going to equal 4435. That's how much money I should deposit if I want to end up with $5,000. All right, I will put some more examples on another video. If you have any questions, let me know.